36th, a charge capacitor discharged through a resistance R with time constant tau. The two are now placed in series across a source of angular frequency omega 1 upon tau. The impedance of the circuit will be what they are saying. We know that what is tau? Tau is RC. What is time constant? RC. What is omega? Omega, we know that XC is 1 upon omega C. So what is omega? Omega we can write 1 upon RC. Omega what we can write? 1 upon, in this circuit 1 upon RC. So what is Z? Z is under root R square plus XC square. They are saying omega is 1 upon tau. Omega is 1 upon tau. Means 1 upon RC. But we know that XC, what they are saying? They are saying कि omega is 1 upon tau. It means omega is, tau is RC, 1 upon RC. But what is XC? XC is 1 upon omega C. And from this relation, what is 1 upon omega C? R. R is 1 upon omega C. Therefore, we can calculate C. R square plus 1 upon omega square C square. So R square plus R square means R root 2. So we will go for C, 36 C. C. Now we are going to calculate for 37th problem, an inductor of inductance 2 Henry, resistance 10 ohm connected in series with 110 volt. We want to calculate current. Current means voltage upon resistance. Voltage is given 110. Resistance means impedance. We have to calculate only impedance. It is LR circuit. So LR circuit means it is resistance, and resistance means impedance. So it is under root XL square plus R square. You know that what is XL? Under root omega L. So omega square L square plus R square. What is omega? 2 pi F. So we are getting 4 pi square F square L square plus R square. Now by putting the values, pi square is nearly 9, F square 60 into 60, L square 4 plus R square 100. Take 100 common, so you will get 10 out of the square root. So it is 36 into 36 into 4 plus 1. You can ignore this 1. So what you will get? Nearly 10 into 36 into 2. So what we are getting now? We are getting now 720. So what should be the value of I? 110 by 720. Cancel 0 with 0. If you divide 11 by 72, we will get nearly 1.15. So we are going with B option. Next, 38. When a DC voltage of 200 volt is applied to a coil of self-inductance 2 root 3 by pi Henry. A current of 1 ampere flows through it. But by replacing DC source with AC source of 200 volt, the current in the coil is reduced to 0.5 ampere. Then the frequency of AC supply is. So what we were doing initial, we are applying only DC source. DC source means only resistance will be active. So what is the value of R? V upon I. What voltage you apply? 200 volt. What current you got? 1 ampere. So Ohm's law, we get resistance value 200 ohm. But what we are doing now? Now we are applying an AC source. What will happen now? Now resistance is there, coil's resistance is there, coil's inductance is there. So it will become now LR circuit. What it will become now? LR circuit. So for I, now we have to apply formula V upon resistance means impedance. What they are saying, it is with AC source of voltage is given, current is given. So we can calculate Z. Z means V by I. Voltage is 200 volt. Current we are getting 0.5 means 1 by 2. So resistance should be 400 ohms. But what is resistance now? Resistance now is under root R square plus XL square. Means 400 is equals to root of R square. What was R? 200. Its square means 2 square 4 into 10 to the power 4. 200 square means 4 into 10 to the power 4 plus XL square. Squaring both sides, we are getting 16 into 10 to the power 4 is equals to 4 into 10 to the power 4 plus XL square. So what we are getting the value of XL square? 12 into 16 minus 4, 12 into 10 to the power 4. It means XL should be square root of 12 means 2 root 3 into 10 to the power 2 means 100. So what we are getting? 200 root 3. But what is XL? XL is omega into L. Omega is 2 pi F. Omega into L. We got 200 root 3. L is given 2 root 3 by pi. So 2 into pi into F into L is given 2 root 3 by pi. 2 root 3 by pi is equals to 200 root 3. Cancel pi with pi. Root 3 with root 3. F means 200 by 4. So we got value of F is 50 hertz. So what we are getting? F means 50 hertz. So we are going with option D. Next, 39th. Switch S is closed at t is equals to 0. After sufficiently long time, an iron rod is inserted into an inductor. Iron rod is inserted into inductor means we are increasing the value of XL. If we are increasing the value of XL, means voltage in L is increasing. They are in series. Voltage is divided into two parts. If that part is increasing, means voltage of bulb will decrease. So it will get dimmer. So we are going with option B. Next. A 50 Hz AC source of 20 volt connected across R and C. The voltage across R is 12 volt. The voltage across C is what we have to calculate? The voltage across R is 12 volts. So you can calculate I. Ohm's law, I is equals to V by R. voltage across R is 12 volt and value of R is not given. Value of R is not given, so we are taking it. A 50 hertz source 20 volt is connected across R and C. So what they are saying, okay, we will go with impedance triangle. What is happening here? See, R is not given, so we will take the help of impedance triangle. VR is in same phase with I, but in capacitor current is leading by 90 degree. It means XC should be in this direction. So it is VC, it is VR. So resultant should be under root, resultant V should be from impedance triangle. VC angle between VR and VC is 90 degree. So resultant should be under root resultant V is equals to under root VR square plus VC square. We know that the total voltage was 20. VR got its share 12 volt. We want to calculate VC. 400 is equals to 144 plus VC square. So VC square 400 minus 144, 400 minus 100, 300, 300 minus 40, 360 minus 4, 400 minus 100, it is 300, 300 minus 40, 260 minus 4, 256. So VC means 16 volt. So we are going with B option, 16 volt. If R should be given, then we can calculate the current in the R, and after that multiplying by that current with XC, we can get VC. Now next, 41st problem. For the LCR circuit, what is the resonant frequency and the amplitude of the current at the resonant frequency? We know that what is resonant frequency? Angular resonant frequency is 1 upon root LC. What is L? L is given 8 millihenry. Milli means 10 to the power minus 3. What is C? 20 micro. Micro means minus 6 farad. So what we are getting omega? 1 upon 2 into 8, we are getting 16. So we are taking 4 out of the square root. What is remaining? 30 minus 6, 90 minus and plus 10 plus. So minus 8 out of the square minus 4, take in numerator plus 4. So nothing is in square root now. 10 to the power 4 means 100 into 100. 100 by 4, 25. What we are getting? 2500 radian per second. So omega we got 250, but there are 3 answers which are 2500. So now we have to move for current. How to calculate current? For current we need resistance. For current we need resistance. So since concept is there, at the time of resonance, XL minus XC, it will become 0. So no voltage is taken by inductor and capacitor. Whole voltage are with resistance only. What voltage we supply? 220. What was the resistance? 44. So from there we can calculate I, because it is the case of resonance. At the case of resonance, resistance becomes 0 along XL and XC. Resistance 0 means V0, because V is equals to I into resistance. So whole voltage resistance will get. So now 22 2s are 22 10s are. So what we are getting? I peak value 5. So peak value of I is 5. So 2500 and peak value of we are getting, but what they are given, I told you they are not talking about amplitude. So it should be RMS value. What value they will give you that is related to root mean square value? It is RMS value of voltage. So we got RMS value of current 5. We want peak value of current. So it should be root 2 times IRMS. So we will go for 5 root 2 ampere. Means we will go for A option. What voltage or what current is given in question? If they are not specified amplitude or maximum, it means they are talking about RMS value. 42. In a LCR circuit, voltage across the resistance, capacitance and inductance is 10 volt each. What is happening here? It means all have same resistance because they are in series, same current is flowing through them, and they are saying all voltages are same. It means they are saying all resistance are same. R is equals to XL is equals to XC. So what total voltage we applied? I into R. R means when 3 are there, R square XL minus XC whole square raised to the power 1 by 2. But what is happening now? They are short circuiting the capacitor. So remove the capacitor. It means now the resistance is only what they are saying ki whole voltages, all voltages are same and that are 10 volt. I into R is 10 volt. So they are talking about voltage 10. Now they are saying we short circuited the. So initially they are saying I into R across resistance voltage was 10. But now means they are saying the value of I is equals to 10 upon R. But now only 2 are in picture, R and XL. XL was also R. So now current is 10 upon, initially current was 10 by R. I am calculated from resistance initial case, but now total resistance is, total current is I upon 10 root 2 R. 10 upon R was previous current. Previous current was 10 by R. So now it is previous current divided by root 2. So new current is this. So new voltage, what should be new voltage now? It will be 10 by root 2 R into R. 10 by root 2 R into R. Cancel R with R. Cancel R with R. So what we are getting? New voltage 10 by root 2. So we are going with C option. Yes. Now we are going to solve this 43rd problem. A series LCR circuit R, L and C are given. We want to calculate bandwidth. We know that bandwidth is equals to resonant frequency divided by quality factor. Bandwidth is equals to resonant frequency upon quality factor. What is resonant frequency? It is 1 upon 2 pi root LC. And what is quality factor? We know that quality factor is 1 upon R, root of L over C, root of L over C. So what we will get? 1 upon 2 pi root LC. If we multiply this, we will get R root C by root L, by root L. So what we are getting? We are getting 1 upon 2 pi. Cancel C with C. 1 upon R by L, R by L. So now we are going to put the value of all. 1 upon 2 pi, pi means 3.14 into R, R is 5, L is 40 millihenry, milli means 10 to the power minus 3. So what we are getting? 5000 divided by 6.28 into 40, cancel 0 with 0. So what we are getting? 4 ones are 4, 4 twos are 8, 4 fives are 20 upon 6.28. Simple calculators are allowed. So now we can go with calculation. What we are getting now? We are getting 125 divided by 6.28. So we are getting 19.9 hertz. It means we will go with option B. We will go with option B. Next. Now it is the last second problem, 44th. A transmitting station transmits radio waves of wavelength 360 meter. Wavelength is given, frequency is not given. The inductance of coil required for a condenser for resonant circuit. We know that for resonant circuit, what we need? For resonance, omega should be 1 upon root LC. Omega means 2 pi f. What is frequency? We know that V is equals to n lambda. From sound we know that n means velocity upon velocity of transmitting waves, 3 into 10 to the power 8. They gave us lambda. So velocity upon lambda is frequency. What is wavelength? 360 is equals to 1 upon root LC. L is not given, we want to calculate, but C is given. 1.2 into 10 to the power minus 6. So in this way we are able to calculate the value of L. So what we are getting, take this on that side. So this implies square root of L into 1.2 into 10 to the power minus 6 is equals to 360 divided by 2 pi into 3 into 10 to the power 8. By squaring both sides, we are getting L into 1.2 into 10 to the power minus 6 is equals to 360 into 360 upon 4 pi square into 9 into 10 to the power 16. We are doing approximation. Pi square means 9. 9 fours are 36, so we are getting 110. 9 fours are 36, we are getting 40. So what is L? Take 10 to the power minus 6 on that side. So 10 into 40 into 10 to the power 6 upon 1.2. Take minus 16 in the numerator. So it will become minus 16. Minus 16 plus 6. It will become, remove this decimal, you will get 110 there. So now 1, 2, 6 and 2, 8 and 1, 9. So what we are getting? 1 by 12 into 10 to the power minus 7. Take 110. Take 110 from this. So see, and 1 4 is also there. It is 4 is also there. 4 by 12. So we are writing this 40 upon 12 into 10 to the power minus 8. So we will get 3 point something into 10 to the power minus 8. So we are going with A option. Next problem. In a series resonance circuit, the voltage across R is 100 volt. R is 1000 ohm. C is 2 microfarad. Resonant frequency is also given. We want to calculate voltage across. We want to calculate voltage across L. We know that at resonant time, all voltage is with resistance. So from that, we are able to calculate the current. Current in resistance is 100 upon kilo ohm means 1000 ohm. So we are getting current is 1 upon 10 ampere. So current flowing through that resistance is 1 upon 10 ampere. What we want to calculate? Voltage across L. We want to calculate voltage across L. So since we know the voltage across the resistance, so by that we got the value of current, and at the time of resonance, voltage across L is equals to voltage across C, means VL and VC are equal. That's why resonance is happening. L was not given, but they are want to calculate VL. So calculate VC. What is VC? I into R. What is R? XC means 1 upon omega C. Now everything is given. I is 1 by 10. Omega is 200 radian per second, and C is 2 into 10 to the power minus 6. Take minus 6 in numerator. So 10 to the power 6 divided by 2 into 2, 4. In denominator 10 to the power 3. So what we are getting? Cancel 3 0 with this. Now 1000 upon 4. It is 250 volt. So correct answer is B, 250 volt. It was LCR circuit. In LCR circuit, whole voltage is with R. So R, from R we got VL, because VL and VC are in opposite direction and they are cancelling each other. What VL is in plus, that VC in minus. So total voltage across L and C is 0. So whole voltage was with I, so we have calculated the value of I. But now they are asking, tell us voltage across only capacitor or only inductance. Only inductance, it is not 0. So we calculate for VC, means since VL, for VL we need XL, for XL we need L, L was not given. But at the time of resonance, we know that VL and VC are actually equal and is in opposite direction. So we calculated VC, VC means I into XC, XC was 1 upon omega C. So in this way we got 250 volt across capacitor. If across capacitor it is 250 volt, across voltage it should be minus 250 volt. Actually VL is ahead of this. Across VL it should be plus 250 volt. Across VC it is minus 250 volt. So net voltage is 0. So we will go with option B. It was the completion of the unit 14, which was alternating current. So next we will move towards unit 15, means optics. Thank you.